Okay, now checking out to see if our derivation at least halfway makes sense. We put in our original numbers, 10 square meters for the area, 4 microcoulombs here, and 3 millimeters here. Now, to use the expression 2 pi k sigma squared, okay, we first calculate sigma, which is 4 microcoulombs over 10 meters squared, which comes out 4 times 10 to the negative 7th coulombs per square meter. And then we do k sigma squared. K sigma squared, well, 9 times 10 to the 9th Newton meter squared per coulomb squared. Sigma is 4 times 10 to the negative 7th coulombs per meter squared. We square that, we get coulomb squared over meters to the 4th. Now, articulating that with meters squared per coulomb squared, we get rid of the coulomb squared, but we're going to have a meter squared in the denominator and a Newton in the numerator. So we have newtons over meter squared. Now, the energy, we want to get energy per volume. Does this give us energy per volume? Yeah, it does. If we insert a meter here and a meter here, in other words, multiply this unit fraction by meter over meter, we end up with newtons times meters over meters cubed joules per cubic meters. Per cubic meter. If I did the numbers right, 4 squared is 16 times 9 is 144. 10 to the negative 7th squared is 10 to the negative 14th with 10 to the 9th. That gives us a 10 to the negative 5th, but 144 gives us 1.44 times 10 to the negative 3rd. Now, I didn't multiply by the 2 pi, which is about 6. So we could get the energy per unit volume, which would be 2 pi times this. That's going to be approximately 9 times 10 to the negative 3rd joules per cubic meter. Now, that's not a lot of energy per cubic meter, so I want to stop a minute and check to make sure this halfway makes sense. And the way I would check if this halfway makes sense is figure the energy, which is Q squared over 2C. We have that up here somewhere. Maybe we don't have that up here. Anyhow, the energy to charge this particular capacitor. So let me just kind of run that through in my head and see if it makes sense in terms of this. The area here is going to be ten square meters separation. Well, I'm thinking I'll do that off camera. Okay, that seems to work. Your capacitance here comes out A over 4 pi k delta x. A is 10 square meters. Delta x is 3 millimeters. You divide 10 by 0.003, you get about 30,000. 4 pi k is about 3.6 times 10 to the 10th. I did that right. Actually, 3.6 times 10 to the 10th pi, which is about 10 to the 11th. So if I divide the 30,000, which is 3 times 10 to the 4th, by 10 to the 11th, I get 10 to the negative 7th. And that's going to be in units of capacitance, 10 to the negative 7th farads, 10 to the negative 7th coulombs per volt. If I square this, I get 1.6 times 10 to the negative 12th coulombs squared. If I divide that by the capacitance, I'm going to get about 1.6 times 10 to the negative 5th. Oh man, I'm losing the numbers. Anyhow, if you work out these numbers, you come out in the right ballpark with this one. So this isn't too far off, so I suspect it might be right. In any case, you can double check the arithmetic here and see if everything makes sense. And you can compare this with the result that you get if you do the work to charge the capacitor, 1/2 Q squared over C, and divide that by your A delta X, your 10 square meters times your 3 millimeters.